Okay, let's come back together now and talk about our solutions. Let's start off with the first problem. So, Liliana, did you find any observations or did you have any ideas of how to start this problem?
We're just asking for how you approach this problem.
Liliana, hi, are you there?
Okay, is everything good now?
Hello?
Yes, we can hear you.
Yeah. So how did you approach this problem? Did you see any observations?
Well, I saw that ALL, it has 3 digits, but since US and AS only have 2 digits, that means that U plus A has to be something that's either equal to 10 or greater than 10.
Yes, that is exactly how you should think when you are doing a cryptorhythm problem. So the very first step is to write out all of the digits for organization. We write it from 0 all the way up to 9, as I did over here. And then what you said was great. You're saying that A, this value, must be a carried digit from the tens place, right? Something was carried over to the hundreds place. And whenever we have two numbers being added together and result in a number that has a greater place value, so you can see that we had a 2-digit number plus another 2-digit number, which gave us a 3-digit number. Whenever you have two numbers being added together, the greatest value you can carry from a place value is a 1. So it means that whenever you carry a value, it has to be 1. This is because, let's say, if you took the biggest digit, which is 9, you did 9 plus 9 equals 18, right? 18 is the greatest possible sum you can get, and 18 contains a 10. So this is why whenever you are adding two numbers together, the greatest value you can carry from a place value is a 10. So do you get that?
Also, I didn't do any of the other ones. I only finished this one.
Mm-hmm. Wait, so do you have a solution? Do you have an answer?
Yeah.
Could you walk us through how you did it?
So, first, well, since, A has to be 1, then it would be something plus something equals like something, like 100 something.
Mm-hmm.
So then, if you, so it's kind of hard to explain, but, since, well, so if it was like made, like, if it was carried down, then they have to be something greater than 10 or equal to 10. So then first, like, it could be that S and S, like, can carry a 1 down. So at first we just said U can be 9 or 8. Like, just see if, like, since if U is 9 or 8, then they would equal.
And then you carry.
Mm-hmm. And then, so we just said, like, if U was 9 or 8, so if we tried it with a 9 and did not work. So if you do it with an 8, and then that means that the two, like, S have to carry something.
And what would they carry? What value would they carry over to the tens?
They would carry a 1 down, so.
Yes.
And then, okay, this is very hard to explain. I don't know how to explain.
Okay, I have a question for you. What would L equal?
L is 0.
Why is that? Why does L equal 0 no matter what?
For some kind of reason, I figured that out earlier. Now I completely forgot about it.
Okay, that's totally fine. So why L equals 0?
Can I just say something?
Yeah?
When you're writing, when you figure out a letter, I think you should write the number like close, like maybe at the corner of it, because it's really hard to see and understand. And also, there's 2 A's, so you could write
Oh yeah.
as one.
So if we know that A is in the hundreds place equals 1, then this A in the tens place also equals 1. And then, okay, let's pretend we don't know that L equals 0 yet. So then you have 1 plus 8 plus 1, which gives you 10. So then L has to equal 0. And if you had U equals 9, and then you had 1 plus 9 plus 1, it would give you 11, right? So then L would have to equal 1. But because 1 is already taken by A, you can't repeat the value again. So L has to equal 0 no matter what. You get that?
I think you can write the solutions in the corner because it's hard to, like, I don't know what is A right now because it's hard for me to see.
Like that?
Yes.
Okay. So then you can see that S has to equal 5. S has to equal 5 because in order for you to be able to carry a 1 to the tens place, something plus something must equal 10. And we all know that 5 plus 5 equals 10. So then S equals 5. Then our final answer would be U equals 8, A equals 1, A equals 1, L equals 0, and S equals 5. That is our final solution. So this was the first problem. Now let's move on to the second problem. Did you guys not have time to move here or to come here?
I think
or
we need,
did you guys try doing it already?
I didn't even start it yet.
Okay, we'll give you some time to look at this and maybe come up with some observations first. Okay, let's try doing this problem together now. So we start off by writing out all the digits from 0 to 9. So you should have 0 to 9. And then what can you conclude about S? What does S equal?
S has to equal 1 because you can only carry 1 down and there's nothing above it.
Yes, so S equals 1. And then it means that a 1 was carried to the 10,000th place. Then, now let's look at the ones place. What can you notice about what's happening in the ones place?
What?
Well, we can see that in the ones place, we have E plus T equals T. And we can see that E plus a number still equals that number. And we know that 0, whenever you add 0 to a number, you are still left with that number. So it means that E must equal 0 because it's taking on the properties as 0. So if E equals 0, then T added to 0 would still equal T itself. And then if E up here equals 0, then all of the other E's also equal 0, like this. And then we have to look in the hundreds and the tens place. When we compare them, we can see that K plus A in the tens place equals equals something that ends in a 0. And then in the hundreds place, we have a plus h, which also equals something that ends in a 0. Do you see that?
Yes.
Okay. So then if we compare this, we can see that k and h equal different values. But for some reason, when they are added to a, they both equal something that ends in a 0. This is a little bit strange, but by comparing this, we can tell that carrying was involved in this. So if in the ones place we have e, which is 0, plus a number equals that number, then it means that nothing was carried to the tens place, which means that the carried number must have affected the hundreds place. We need to include this carried 1 in order to make the difference between k and h. So now, after looking at this hundreds column, we can rewrite our equation as 1, this is the carried 1, plus h plus a equals something that ends in a 0. And we can also conclude that in the tens place, k plus a plus e equaled 10 in order for us to be able to carry over. And 1 plus h plus a also equals 10. So do you have any ideas of what to do next?
Well, I have an idea, but maybe it's not about what to do.
Yeah, try it. Try telling us.
Well, h plus a has to equal 9 because 10 minus 1 equals 9.
Exactly. H plus a must equal 9. And then in the hundreds place, we know that 1 plus a plus h equals 10, right? So then something was carried to the thousands place as well. There's a lot of carrying in this problem. And in the hundreds place, we can see that 1 plus t equals a 2-digit number. By looking at this, we can tell that h must equal an odd number because it's 1 more than t plus t. So all of the odd numbers we have available for us right now is 3, 5, 7, and 9. And we know that h cannot equal 9 because by looking at this equation, h plus a equals 9. So h itself cannot equal.
Why would h be odd? Sorry?
H would be odd because if you look in the thousands place, you see that 1 plus t equals h. If t plus t itself already equals a even number, then 1 plus an even number must always be odd. Do you get that?
Oh, okay, yeah, I see.
So that's why h must equal an odd digit. And then when you look in this equation you just wrote, h plus a must equal 9. So then h itself cannot equal 9. So h has 3 different possibilities, 3, 5, or 7. So, and we know that t's value is actually dependent on h. If h equals 3, then t equals 6, because 6 plus 1 gives us 13, and h would equal 3. So now this is where a little bit of trial and error comes in. Because we've come up with all the different possibilities, we have to now actually test them out in order to eliminate them. So if h equals 3, then t equals 6. If h equals 5, then t equals 7. And if h equals 7, then t equals 8. Is that a thumbs up or a thumbs down? Okay, so that's a thumbs up. And then t is also shown here in the ones place. So we can, oh wait, never mind. And then we know that e must equal 0, and k is always going, and k is always going to be 1 more than h. You see here how we have k plus a equals 10 and then 1 plus h plus a equals 10? It must mean that k and 1 plus h it has the same value. So k is always 1 more than h. Let's go back to the slide and see what we have so far. So
Kaylee, you remain paused on what your share screen right now. I just want to just make a comment on, like, Liliana, just notice how Kaylee, when she's solving really complicated cryptograms like this, look at her, how organized she is, right? She's not losing track of what she's thinking because first, on the top, she has, all the possible digits written out from 0 to 9. She crosses them out as she, gets more solutions. And then she has another system for, like, the individual letters and what they mean. And all her thinking on the bottom, all her thinking and her logic is written out. And this is what's so important because logical thinking is not just about thinking, in your head. You have to write it down. You have to write everything down. So that's just what I quickly wanted to add.
So we know that a plus h must equal 9. And then a plus k must equal 10. So that's why k must equal 1 more than h. So let's switch back to the slide to organize our solution a little bit more. This was for the previous problem. So this is what we have so far. From carrying, we can notice that h must equal t plus 1. This means that h must be odd. This is why h can be equal to 3, 5, or 7. And then through trial and error, we get the final solution. So going back here to what we were just doing, we have to do trial and error. So if t equaled 6, then h must equal 3. And then the t over here would also equal 6. So then would also equal 6. And then the h here would equal 3. Now when we look in the hundreds place, we see that a in this case must equal 6. And this tells us that this first solution does not work because t and a cannot equal 6 at the same time. So that's why we have to try a new solution. If h equals 5, then t, as shown here, must equal 7. And then this a over here must equal a 4 in the hundreds place, here as well. And then k would equal 6. And yes, this does work out. But we still have to test the final solution. The final possible solution. If h equals 7, then a must equal 2. and t would equal 8. In this case, k would also have to equal 8, but k and t cannot equal 8 at the same time. This is why this third possibility will not work out. Now, knowing this, we can tell that h must equal 5 and t must equal 7. And that brings us to the final solution, which is t equals 7, a equals 4, k equals 6, e equals 0, h equals 5, s equals 1, and that is our solution.
Is there a way you could write that out? Because it's kind of confusing.
Okay, yeah, so basically, let's start from the beginning here. So we know that s must equal 1, right? Because it's carried. And then we can tell that in the ones place, e plus t equals t. You see how e plus t still gives us t? It means that e is 0 because it's taking on the properties of 0. When you add 0 to a number, it's still that number. And then we see that h is equal to t plus 1. This must mean that h has to be a odd number. So then h can either be 3, 5, 7, or 9. And then because we know that t's value depends on h if we look in the thousands column, right? Because t plus this carried 1 that's supposed to be on the top here. Let me switch into pen. So there's actually a 1 that's carried up here. So then 1 plus t depends on the value of h. So then we can write out the values of h and t on top of each other as like, so let me So if we look here, we can see that what we did was we wrote the possible values of h and t on top of each other. If h equals 3, t equals 6. If h equals 5, t equals 7. If h equals 7, then t equals 8. And then knowing this, we tested out every single one of these 3 possibilities. And then in the end, eliminated these 2. So our final answer was that h has to equal 5 and t equals 7. And then knowing this, we can just plug the values in and then find the rest of the solution. Do you get that?
Mm-hmm. Can I add something else? So to solve this problem, right, after we know what t equals, we know what s equals, and we know what e equals. After we know what s and e equals. The rest is the process of elimination along with trial and error. If you look at the relationship between the middle two place values, which is a and k especially, we know that k plus a is equal to 10. But we know since there was 1 carried over from the 10 to the hundreds, we know that k has to be a plus 1. K has to be 1 more than a. So, Kayla, if you write this down, k is equal to a plus 1. K plus a is equal to 10. The only set of numbers that, are fit into that category is 6 and 4. So that is another way how you could directly get the values of a and k. K is equal to a plus 1. Just moving on.
Okay, so let me go back to the slide now. So our final solution was 7,460 plus 7,547 equals 15,007. So cryptorhythms has a very large range of difficulty. It can be very easy, like the first one, and it can get progressively harder. And there can be different operations that cryptorhythms can include as well. So I don't think we have enough time today to do the third one. So I feel like right now this is a good place to stop.
Okay, go on to the last slide. Yeah.
So yeah, thank you for joining us.
This is the end of our, summer boot camp open house. I hope you enjoyed our class. I hope you learned something new, and we look forward to seeing you this summer. A feedback form we will send out to you guys afterwards. It's just about how you thought of what you thought about this, meeting. So please fill it out to help us. Bye, Liliana. We hope you enjoyed and you learned something new.
Bye. Thank you for joining us.
Thank you.
Thank you. Bye.
Bye.